on those seemingly rarer and rarer occasions when we do get a decent snowfall here in North London, the green grass of the local playing fields is covered in a beautiful crisp layer of whiteness. However, this very quickly disappears, and within a couple of days there's no sign of it at all and the green grass is back. But not all the snow goes. Where it's been rolled into huge balls by adults and children, these balls can stay around for days and days. Why is this? After all, snow is snow. The answer is not as simple as you might think. We're going to assume that the air above the field is at around about 5 degrees Celsius and that all the snow is at 0 degrees Celsius. None of it's melted yet, so it's all snow at 0 degrees Celsius. The air around being at 5 degrees centigrade will pass its energy to the snow. And this happens firstly at the surface of the snow, which is kind of obvious. The snow has a flipping enormous surface area when it's laid out flat in the field, and therefore loads of energy can quickly flow in from the air to the surface of the snow. A snowball, on the other hand, of course, is all squashed up and round and therefore has a much smaller surface area by comparison, and therefore is going to take in heat more slowly. And of course you'd be right, and on one level you could sit down and say, right, that's the end of this discussion. But as you might imagine, there's kind of more going on here. Snowflakes are really rather beautiful structures, and around them you can see that there's a lot of space again for air currents to flow around the arms, for example. Then if you imagine snowflakes falling on each other, again, they're not squashed, so there's more space between the individual flakes. The point I'm making here is there's a lot of opportunity for air currents that are warmer than the snow to flow around the snowflake and transfer their energy to the snowflake. Let's consider the making of these great big snowballs that you can see on the field. In the process of rolling these balls around and gathering up the snow, you're squashing the structures, breaking the arms and pushing them closer together, thereby, I would say, dramatically reducing the opportunity for air currents to flow around inside the structure of the snowball, meaning again that the snowballs are going to take longer to heat up. Water is a truly wonderful substance. It has several unique properties without which life as we know it just wouldn't be able to happen. Perhaps one of its lesser known strange properties is that if you apply pressure to ice, you can change its melting point. Now this happens best if the temperature of the ice is around about 0 degrees, maybe -1 or -2. But if it gets much colder than that, this effect is harder to notice. As you pick up the snow to make a snowball, you squash it. The fact of squashing it increases the pressure around the snowball, and this in turn lowers its melting point, perhaps from 0 to -1. But this can be enough to cause part of the snow to liquefy in the snowball, in other words to become water. Now it's not that you get a snowball, you squeeze it, and you end up with a puddle of water in your hands. That's not what happens. It's more subtle. As you squeeze it, little areas of the snow in the snowball will melt and become liquid. Then when you let go of the snowball, or you release the pressure, the melting point returns to its original value. And so the liquid water that you've created can turn back into, in this case, not snowflakes, but ice. The thing to take on board here is that as the liquid water returns to solid water, it's not returning into the structure of snowflakes with lots of space around the arms and so on. It's returning into a solid where there is no room for the air currents to circulate within it. Therefore, once again, it becomes harder for energy to flow into the snowball. One question that occurs to me about this that I was unable to get an answer for is the specific latent heat of fusion of a snowflake the same as it is for ice? In other words, is it that the structure of the water is different in the solid within the solid of a snowflake compared to within the solid of ice? I was unable to reach a conclusion on that one. Perhaps you've got some thoughts on it. Since physics is all around us in our everyday lives, if you found this video about snowballs interesting, you might find this one on bass guitars and resonance interesting.